Started.
Thank you very much. We move on to Sally Dr. Gupta and will remain in the field of penetrating cell sequencing, and in order to bring pressure for others, we will be talking about SDG, among other things. This topic is not model. So, Sally, go ahead. Good morning, everyone. It's a matter of extreme pleasure and gratitude for me to greet you all in this prestigious ICA symposium. I am Sunny Dutta from the group of Professor Albert Duschel, and now I wish to take this wonderful opportunity to take you all for a short journey through the progress of my PhD thesis in my first year here so far. So my PhD thesis gives me a very exciting platform to study and explore in deeper details a very interesting set of cytosolic receptors known as the nodes. They have been so far mainly reported to be playing a crucial role in the recognition of different peptidoglycan components and henceforth elicitation of inflammatory immune responses, or say a mutation in them is reported to be found in chronic inflammatory bowel disease. But we believe that in addition to such definitions, they could be bearing a much wider implications in the modulation of the immune system, and hence we aim to study their role in the regulation of NF-kappa B and STAT-mediated signaling pathways. So, let me give you a short overview of how the receptor looks like and their mode of action. The receptor comprises of the three domains. At the C-terminal, we have the leucine-rich repeats domain, which is in fact the domain responsible for the recognition of the specific ligand for NOD1 and NOD2. I will come up to these ligands in the subsequent slides. This is followed by the oligomerization domain. NOD is abbreviated for the nucleotide oligomerization domain containing proteins. This is a self-oligomerization receptor, and upon the recognition of the ligand, it leads to an oligomerization. And it is followed by the caspase activity recruitment domain, through which these receptors interact with a common downstream kinase known as RIC or RIC2. Both NOD1 and NOD2 have been reported to be interacting with RIC. This is followed by the subsequent immune response and the inflammatory responses. So taking these points into consideration, we move ahead with our aims, but beforehand we wanted to validate that our experimental procedures are fine, the experiment work on our hand, and if we wanted to validate our method. So here is a very basic preliminary experiment in which we did overexpression studies of NOD1 and NOD2 in HEC293 cells. These are transient transfection experiments in which the reporter gene is for NF-kappa B is transfected, and here we could see that overexpression of both NOD1 and NOD2, we have a clear elicitation of the NF-kappa B, the constitutive NF-kappa B activation. This fell in line exactly with the already published data, and hence we were successful in validating our method, and hence we could believe that the experiment worked in our hand. So here I want to mention briefly that in this study, the amount of DNA being transfected is always leveled up with the pcDNA. It's a dummy DNA, so it's an effect that we observe, and rather than an effect of only the concentration of the DNA itself. So here I want to mention briefly the ligands that the NOD receptors recognize. NOD1 recognizes IDA, also locally called the gamma glutamyl diaminophilic acid, mainly from the gram-negative bacteria, whereas NOD2 recognizes muramyl dipeptide. This is, as I mentioned earlier, is recognized through the leucine-rich repeat domain. Upon oligomerization by the NODs, there happens the card-card interactions with the downstream kinases, which leads to the subsequent immune response. So now we wanted to see that what effect the ligands have in the activation of NF-kappa B by the NODs compared to when the ligands are absent. And here we could easily observe that IDA presence for NOD1 and MDB's presence for NOD2 bears a high enhancement of the activation of NF-kappa B compared when the ligands are not present. But just comparatively in both these data, we found that the activation of NF-kappa B with IDAP and NOD1 is comparatively a bit more than the case of MDP and NOD2. So at this point of time, we just thought of selecting NOD1 for our subsequent experimental setup. This actually don't mean that we have neglected NOD2 for our studies. In fact, experiments regarding NOD2 are extensively going on at present. But for the time being, for my subsequent slides, the data I'm going to discuss with you all deals mainly with NOD1. So now we were interested to see that what could be the possible effects of these domains that I described so far. And I'm greatly thankful to Professor Robert Schottenberger for providing us with this wonderful deletion constructs. And here we could see that when the card domain is deleted over here, we can easily observe that there is a drastic abolishment of the NF-kappa B activation that is being observed in the wild type. But the most interesting thing here is when the ligand recognition domain, the LLR domain, is deleted, the effect is still maintained as we see in the wild type. So this somehow challenges the role of the ligand itself, and it in fact also falls in line with my very preliminary experiment where just the overexpression of the receptor itself leads to the observed phenomena. So what could be the real reasons for that? We have to look more into the details, and the experiments at present are going, and we also wish to subject further deletion constructs in these studies. So far as the NF-kappa B story was concerned, this was our progress so far, but we are looking forward to it further. But apart from this, we were also interested to see that whether NODs have any implications in the modulation of the JAK-STAT signaling. And to accomplish this, we did similar overexpression studies in egg cells where we studied different STAT setups. And here you can clearly see that as far as STAT1 activation is concerned, we don't observe a very clear effect with NOD1. But as far as STAT3, STAT5 and STAT6 is concerned, all the three show that with an increasing dose of NOD1, there is an inhibition of the STAT activation. But this data got more pronounced when we included the specific inducers of the STAT. And again, we could see that as far as the STAT1 activation activation by IL-6. Though we also see a nice effect with STAT5 and also an inhibitory effect with STAT6, but for us, the most pronounced effect for the time being is STAT3 activation with IL-6. So we decided to go into more details into this particular experimental setup, and again, we subjected the activation of STAT3 with IL-6 using different deletion constructs. Here again, you can observe that the wild type NOD1 with an increasing dose leads to an inhibition of the STAT3 activation. This, surprisingly, to somehow is still retained both in delta CAR and delta LLR. Like here, either the LLR domain is deleted, the CAR domain is deleted, but we are not that sure of why the effect is still retained here. So maybe to validate this particular observed phenomena, we need to look using further deletion constructs or constructs having specific domains only, because I want to stress that here, though one domain is deleted, but say the NOT domain is present, so we are not sure of this particular hypothesis, but we have to work further to become more sure of this phenomenon. But just to believe that the phenomenon that we are observing is an effect and not an artifact, we included a control experiment over here where we used the overexpression of SOX1 mutant, and to our delight, we could find that there is almost a complete abolishment of the nice inhibitory effect that we observed in the case of NOD1 wild type. And this was quite boosting for us, and we could easily believe that the observation we are having is in fact an effect rather than any artifact. So this was really quite exciting for us, and we are looking forward to do further experiments in this setup. So far, we were glad that we successfully validated our experimental setup, our methods at the beginning. We could observe that NOD1 overexpression has a clear effect on the activation of NF-kappa B and STATs, but in completely contrasting manner. As far as the NF-kappa B activation is concerned, NOD overexpression leads to an enhancement, whereas as far as the activation of STATs is concerned, it leads to an inhibition. And of this inhibitory effect, this is retained both on the constitutive as well as the inducer specific activation of the STATs. And in this STAT setup for us, the most exciting so far has been the activation of STAT3 by IL-6. So further, we would like to elucidate and find which domains are really responsible for the observed effects that we have so far. We would also like to find that what could be the possible interacting partners of NOD1. We would also like to go more into detail of the NF-kappa B experimental setup, and in fact I want to mention the experiments are going on now. I expect some results by this weekend, and that what would be the inducer's specific activation being affected by overexpression of NOD1. And finally, we would like to extend our studies to dendritic cell to add more valor and biological significance to our data, and finally arrive at a point where we could really learn and understand and help others understand that what are the viral implications of NOD1 in the modulation of the immune system. So finally, I'd like to thank the members of my group thank my friends for standing by me in hard times. I express my deepest regards to Professor Schwarzenberger, and I seek his blessings further for the progress of my PhD. And finally, I extend my deepest regards to Professor Self-Halomer, my supervisor Jutta, and above all, my mentor Albert Duschel, to provide me this wonderful opportunity of my lifetime to become a better scientist.